Alright, so we now revisit the bulls and cow problem. I'm not repeating this instruction of this how to play the game, but please watch the previous lecture. Okay, in the previous lectures, we write a script to compute the bulls, right? Okay, let's review the solution for computing the bull. Okay, we used the if statement to compare the value at the individual location from the two variable x true and x test, right? And then the first location check, second location check, third location check, and fourth location check. Okay. Later on, if you see these types of the script, you have to come up with the loop solution. Why? You can change this one as a loop variable because this is the same action, right? You get my point? So that's why everything is the same, and then you're making the loop, and then accessing the location of x true and x test using the loop variable. Okay, place the action here. Okay, you can significantly shorten this code, but this is the the simple example. But if you this size is very large, you cannot solve it without this loop statement. Okay, this is a very good example, I'll say. Okay, now we are solved a bit harder problem. How to compute the cow? Cow is if the digit is present in both the trier and chosen number but is not in the same location, this is called a cow. So meaning that cow plus a bull become the numbers of the digit that are presented in both the sequence. Okay, I'll repeat this again. Cow plus a bull is the number of digits that are present in both sequence. Okay. To employ this value, you need to take the double loop structure so that you can inspect every single pairs between the true and then test the vector test element. Okay. The reason why we are making this double loop structure is that II is accessing the element in the true vector, and then ZZ is accessing the value in the test. Okay, II is equal to 1, and then we are going to test if there is the same digit in the X test using the inner loop, right? Once I finish that, go here, then second one, and then inner loop is to check if this digit is the same with this one. Okay. At the end, num C is not cow here. Num C is this one. Num C become numbers of the overlap. Do you get this point? Okay. So let me show this example here in the MATLAB. I put the break mark here. Run it. When this code stops, II is equal to 2, Z is equal to 2. Why? I is equal to 2 is a 2, Z is equal to 2, right? So guess what? When this could stop again? II is equal to 3, ZZ equal to 1. Okay, like this. Okay, what else? Do you think that could stop here again? No, right? Because there's no overlap. Okay? Later on, we will revisit this problem again because there is the better solution. Okay, very common is to escape the loop structure in the middle of the iteration and to terminate the loop. So the break comment is to only terminate the current. This is the current. And closes the loop structure. Okay. For instance, if a break is break comment inside of the nested as like a double loop structure, this only the terminate the inner loop. Okay. Let's take a look at this example. Okay. So II is not equal to 3. This one is a skip, right? So II vector 1 is equal to 1, vector 2 is equal to 2, II is equal to 3, and then break comment is executed. So what happened? Break comment is brings you to the outside the loop. Okay. So what is the vector looks like? 1, 2, and 0, 0. Okay. We are not executing the after break comment. So here we are not executing this one when the II is equal to 3. Okay. This is a very important, okay, to understand the break. Okay. The break does not complete the current iteration. Let's say when the II is equal to 3, break, and then this one is directly, that brings you to here, not the go through here and then stop. Okay, that's why the 3 is not assigned to this vector. Okay, makes sense? Okay, the question is when we use this break statement. When we use this break statement. Okay, let's solve this example. Okay, find the first appearance location of the A in a character vector named as a character sequence, and then assign its location, the index, to the LC. Again, the manipulation of the character vector is exactly same as the one in the numeric vector. The only difference is that the character vector contains a character in each element. Okay. This question is asking the first appearance of the location of the A. Okay. The programming logic is reading each character in the character vector and then compare with this A, right? So you should develop this logic, right? Okay. Now you can easily design this one without this break. Okay, reading the first character and compare with A. Okay, and then assign the location. Okay, and then go up, second location, compare A, and assign the location F. The character is A. Okay, the problem of the difference of this problem is the first appearance. Okay, first appearance. Okay, this means once you detect A, you should not continue this loop structure. Why? Let's say this first location is the 9th location here, and then if you continue this loop, you will get the location of this one, right? So that's this this question. Okay, what if we can run without the break comment? You will get the final appearance location of the A. Do you see my point? Okay, so you should stop it and then stop and then escape from the loop structure so that we can get the first appearance of the A. Okay, that's why we put the break comment here. So when the II is equal to 9, and then read this character that are equal, assign the location, and then break outside of the loop structure. That's why you can get the right position of the first appearance of the A. Okay? Okay. You could design it like this. Okay? So maybe some students that design this code maybe like this. Let me delete this one. Okay, and then rather than 0, you're making the location I'll say location all. No, let's location. And LC like that, and then L. First the location. Okay. This script is to find out all location of the A, and then we pick the first one. So if you run it, A, so you can get the correct A location. Okay, let's compare this script with this one. Okay, what is the advantage of this script? Answer is more efficient. Why? We don't need to continue to process this loop structure, because our goal is to find out the first A location. Once you find the A, you're done, right? You don't need to continue this loop. I'm going to introduce another form of the loop statement called the while loop. Different from the for loop, the condition statements can determine the continuation of the iteration or not. This means the script keeps repeating the action as long as the condition statement is true. This is not counted loop. Okay, so this is a syntax while condition action. So if a condition statement is true, this action is executed. Okay, since a condition comes before the action, if the condition will be first, in the first time, these actions will not be executed at all. It's like an if statement. Condition is a false, it's skipped. Okay, so but as long as a condition is a true, action is keep repeating. Okay. But here's the question: how does the while loop stop execution? Because action create the value, and then this value is changing this condition from the true to false, so that this iteration stops. Okay, that's why sometimes if you set up the incorrect condition statement or incorrect logic to update the condition statement, an input loop can often occur. That's the problem. Then your code does not stop on its own. You need to press the Control C to force to stop the code. Okay. So we can sum the range value using the while loop. Okay. For example, let's sum the 1 to 10 using while loop. val is a variable. We can assign this summation value. Okay. So what is the condition? We are going to, to add a num from the 1 to 10. So we are going to set up the num is less than 11. Okay. So here, assign the 1 to the, okay, assign 0 to num. Okay, that's not correct. Okay. Assign the 0 to val, right? 1 to num, right? Okay. So here's the num is the number. Val is the summation value. Okay, then step 2 is the condition is true because 1 is less than 11. So this action is executed. What is the action? You're adding the num to val, right? Num to the value. So now, maybe it's up to this point. Val is the 1, right? 1 is added to the val. Num become a 2, right? And then go up. And then now, num is the 2. 2 is less than 11. So action is executed again. Then the val become a, here, val become a 3 because of 1 plus 2, 3. And then num become a 3, right? And then keep iterating until the num become a 10. Num become a 10. Here's the num become a 10. And then go up. Num is still less than 11. So 10 is added to val. And then num become a 11, right? Num 11. Then condition is false. So it's a skip this action and then go out. Okay? That's the logic. Can you get this? How this while loop iterating the repeating the action and then how to escape the loop statement? Okay. This is similar to the for loop structure. The biggest difference is this is not a counted loops. So we don't set up this number of the iteration in the beginning. Okay. Okay, so let's solve another problem. Okay, find the location of the first three of the 5 in a vector and assign its location to the LOC. Okay, it's not a first 3, it's the first third of the 5. So in this case, this one. Okay. In the location. Okay. How to write this code? Okay. But in this question, let's assume the number of the 5 in vector is more than 3. Okay. This is your input. Okay. Num5 is the number of the 5. Index is 0. Okay. Indexes will be the location of the 5 at the end. Okay. This is the good example of the while loop usage. Okay, let's see the code. Okay, num5 is less than 3. This one, so num5 is the counting the number of the 5 because we are going to detect the third of the 5 in the vector, right? And then you're increasing the index. Okay, and then index become a 1, right? 1. And then you're checking the first value is a 5 or not. Okay? Then if it's a 5, you're increasing the number. Okay? And then go up. And so adding the 1 to the index become a 2. Varying this one. If index is a 3, that condition statement is true. Num5 become a 1. Okay, go up. Index is the 4. This condition statement is true. Num5 become a 2. Okay, then go up and then index become a 6. Index become a 6. This is a true, and num5 become a 3. And then take a look at the condition. Num5 is not less than 3. That's why the condition statement is false. So here, skip this action and then go out. Then you're assigning the index value to the location. Does it make sense? Okay. So the reason I index a variable is to, the highlight this IDX is to access the, the value in the vector, but you don't have to define the index. You can directly define the LOC here, and then do this operation. LOC become your answer for this equation. Okay. So we can design a different condition statement for while loop. This is a code from the previous slide. This is the new code. Okay. Think about it. This condition statement is a num5 is a less than 3. Do this iteration for detecting when does a num5 become a 3, right? This is the same thing with, because the num5 start from the 0. We can, define this statement like this. Num5 is not 3, do iteration. Because when the num5 is 3, condition is a false, and then let's go off. Okay? I will not say that which one is better than the other, but the syntax is varying depending on your application. Okay? Actually, while loop statements can be completely replaced by the for loop and break. The idea is that when the number of the 5 is equal to 3, then we can just escape from the for loop statement and then terminate the iteration using the break. Here's the example. This is the code from the previous slide. And then this one is the same, and then we set up the loop range of a for loop. And then equal to 5, increase the num5. This is the part to make the same with this while loop. If num5 is equal to 3, assign the location of the index location to the LOC, and then break, and then this loop is terminated. Then this II location is the location that we are going to find. Do you see this similarity between this code? I think the outcome is exactly same. Okay, but the logic is different. Okay, while loop is every time they check the condition. Okay, to see if they need to do the iteration or not. Okay, but for loop is the basic assumption is that they're going to do the iteration until this iterator is reached to the end of the range. So once this action part is finding the third 5 in this question, we just stop this stop this iteration and then go out from the for loop. That's the logic. Okay. For me, I rarely use the while loop because we can realize the same operations using this loop statements. The reason is one major drawback. I already mentioned that it might be cause infinite loop if I don't set up the proper condition statements. But regardless, students need to know how the while loops work and can write a scripts using this. Okay? Make sense? Okay, good. Okay, this is the last topic in this module. I'll give you a hint for the next two module. Do you remember dot product? This dot operations between two vectors is basically element-wise multiplication and summation of those values. Okay, let's see how to write a script to perform this dot operation. Okay, based on what we learned so far, we can perform the element-wise operation using loop statement. Okay, first let's write a code element-wise multiplication using the loop statement. We can make the vector, two vector a and b, initialize a and b with the 1 by 5 row vector, and then count the number of elements. And then we are initialize the output vector. Size of the output vector is the same as the size of the a or b. Okay, and then we are accessing each value at the same position of a and b, and then multiplication, and assign this value to the av vec. Okay, we already learned about computing the a vec, like a element wise is like a dot multiplication, right? This is the same, ab vec can be computed using this dot multiplication, but you can compute this value using this loop statement. Okay, and then AB is our final output. We are going to summing up this all value with the logic that we learned in the beginning of this lecture. But in here, take a look at this part. So we use the same loop iteration 2 times, right? So we can merge in this loop structure as one to improve the efficiency, because we don't have to do iteration this 2 times, right? Same iteration 2 times. And so this one you can merging this two operation as one single line. Okay, so in this case we don't have to compute AB vec, right? We can just directly adding this value to the AB, right? So we can write this script from this one. We can shorten this script. Okay? This is much more efficient and then readable rather than this, because defining this vector is unnecessary. However, there is a simpler way. We can use the built-in function. Okay, when let's say you want to do the dot product using the MATLAB, first step that you're going to do is googling dot operation MATLAB, and then you can find this dot function. Okay, so to find out the dot product a and b, you can use the dot a b, then you're going to compute this, you can find this value. Okay, again, the most basic operations were already built-in function in MATLAB. As many as you know the built-in function, we can shorten your code and reduce the mistake to realize those operations. Or you can use the operator. How? This one. We learned about this one. Matrix multiplication. Okay? We can simply a matrix multiplication B transpose, then you get AB value. Okay? These are two topics. Built-in function is operators will be studied in the next two modules. So again, understand this programming logic, loop statement, if statements is very important because they are fundamental in the programming. So we'll do practice the loop structure and if statement in the rest of all the homework assignment and tutorial. Again, the best way to learn the programming is to solve the problem using your own code and keep improving them based on the model answer. Okay, that's it for today, and then see you next lecture. I think the module 5 and 6 is the most interesting part in this course. Okay,